Well, I don't know any other, but I would guess that other trends like quadratic or exponential can also be used to interpolate.
Interpol is late to a mind-blowing math hack. The full story is an episode of the Degrees of Freedom Project, videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description.
If you needed a value from a data table and it was someplace in between the data values, what would you do?
I would do some kind of interpolation, usually linear interpolation because they're close, so we can, I guess, assume that the relationship between them is linear.
What is interpolation, since you said you'd use it?
Interpolation is when you take a value, like you said, that's not on the table or that you didn't actually measure, and you find a value between them using the trend.
This video discusses the basics of linear interpolation in 1 and 2 dimensions. Before the age of readily available computers, most engineering data were only available as tabulations, usually in handbooks, but sometimes in textbooks or journal articles. Data tables still find extensive use. Here's a portion of a steam table. What would you do if you were looking up a value in the table and needed the specific volume of steam at 9 degrees Celsius? Well, it lies between 8 degrees Celsius and 10 degrees Celsius, where you see the oval here. We could sort of guess that it's someplace between 120.8 and 106.3, so it's probably about 110. Is there a more formal way to go about finding this value? Here we have a blow-up of the part of the table that we were just looking at. The most common practice to find the value is to use linear interpolation. You assume that the specific volume of steam between 8 degrees Celsius and 10 degrees Celsius is a linear function of temperature. Is it a linear function? Well, if you think in terms of a Taylor series, any function that can be expanded as a Taylor series is linear over a small enough range, and nonlinear over a large enough range. The trick is to have the table values spaced closely enough together that you can treat the data as being linear. What is the linear interpolation formula? Well, I have a poor memory, so the only way that I can remember it is that the slopes are equal. So what we have here is that the dependent variable y value that we want, minus the y1, which is a table value, divided by the independent variable that we know, x, in this case 9 degrees Celsius, minus the x1 table value that corresponds to y1, in this case 8 degrees Celsius, is equal to a table value y2 minus table value y1, in this case 106.3 minus 120.8, divided by the corresponding table values x2 minus x1, in this case 10 degrees Celsius minus 8 degrees Celsius. Does it matter which table value pair we choose as 1 and which table value pair we choose as 2? No, you can use the points in either order. Just make sure that you're consistent. Rearranging the equation and solving for y, which is the value that we're trying to interpolate for, we get the following formula. Y equals y2 minus y1 over x2 minus x1 times x minus x1 plus y1. If you think of it in terms of the equation of the line, we have the slope y2 minus y1 divided by x2 minus x1 times our independent variable x minus x1 plus the intercept y1. Substituting it in for the temperature and specific volume, we have that v hat is equal to v hat 2 minus v hat 1 over T2 minus T1 times T minus T1 plus V hat 1. Substituting in the numbers, 106.3 minus 120.8 divided by 10 minus 8 times 9 minus 8 plus 106.8 equals 113.6 cubic meters per kilogram. That covers the basics of linear interpolation.
Can you name any other types of interpolation besides linear interpolation?
Well, I don't know any other, but I would guess that other trends like quadratic or exponential can also be used to interpolate.
We discuss other methods of interpolation in the next video, no clear interpretation, a mind-blowing math hack. They are useful when high precision is needed, especially on a widely spaced table.
Do you know what double interpolation is?
No.
Now we'll discuss double interpolation. This comes about if you're between values in a two-dimensional table instead of a single-dimensional table. Here we have part of a steam table. Let's suppose that we need an interpolated temperature of 125 degrees Celsius, which we see is between 100 and 150 degrees Celsius, and a pressure of 0.3 bar, which we see is between 0.1 and 0.5 bar. The specific volume, which we are looking for, is in between all of 4 of the values, as you can see in the middle of the table. So what do we do now? Give me a moment to write down the important values. Well, we use double interpolation. It's called double interpolation, but we actually have to do 3 interpolations. It's called double interpolation because you are doing it in 2 dimensions. Let's start by interpolating on the temperature first and then the pressure. In this case, we'll interpolate at 0.1 bar. Between 100 degrees and 150 degrees Celsius at 125 degrees, we'll interpolate getting 18.35. By a similar process, we interpolate at 0.5 bar between 100 and 150 degrees Celsius at 125 degrees Celsius, getting 3.655. Our final interpolation will be in our column of 125 degrees Celsius, and we'll interpolate between 0.1 and 0.5 bar, getting 11.003. Obviously, you would round these values to have the same number of sig figs as in the table. We're not rounding here so that you can see all of the digits from the interpolation. Next, let's interpolate on pressure in the 2 temperature columns, and then we'll do one final interpolation using temperature. First, we'll interpolate at 100 degrees Celsius between 0.5 bar and 0.1 bar. We end up with 10.31. Then, using a similar process, we'll interpolate at 150 degrees Celsius between 0.1 bar and 0.5 bar and get 11.695. Finally, we'll interpolate using temperature along the 0.3 pressure row again, using 125 degrees Celsius, and we'll end up with 11.003 as the final answer. You'll note that the 2 answers are the same. That's because if you're doing linear interpolation, among the 4 values, it doesn't matter what order you do it in. There is a link to a spreadsheet with these examples and the non-linear interpolation examples in the description below. The takeaways from this video are: 1. If you have a table of values and you need a value that isn't at one of the table entries, use interpolation. 2. You can rederive the formula if you can remember that slope equals slope. 3. For a table with single independent variables, use 1D linear interpolation. 4. For a table with 2 independent variables, such as temperature and pressure, use 2-dimensional interpolation, which actually requires 3 one-dimensional interpolations. Thanks for watching. This video is brought to you by the DOFPro team.